So we had this topic and okay, we should go to the other topic. Next topic. But not so fast. So I put there another little quiz that's called graphs. That's really easy as well. But as we were going through the graphs, and I found that kind of exercises that were, well, they are not like difficult as well. And then, of course, so that's 1 point more. And then I also put one quiz into the here. So there were only only two, and now there's 3. So we got 2 points more. So I have to calculate again the points a bit, change a bit, like the sort of the gradient. It doesn't do much, but still. Oh, okay, whatever. But we are not there anyway. But maybe somebody already is doing that topic. So here is suddenly one little quiz more. Then we were going through this inverse function, and I wanted to say one more thing about it. So we did this inverse function for this Fahrenheit and Celsius thing, the exercise, yes. Inverse function, and it reverses the effect of original function. Okay, and then were these steps, what you need to do. And then there was one example, but then I didn't finally go through it with this example that I did. So then I realized that was missing. Now I lost my thingy. What do I do? Yeah. Oops. Okay. So this was the example or the exercise that we did. So we did first. Maybe I have to move this away as well. Yeah. We did the graph the sort of wrong way around because we wanted to know then finally how much is 100 Fahrenheit in Celsius, but we made first this graph so that it's a Fahrenheit heights in function of Celsius degrees. So then we reversed it the other way and went through this, just put the axis the other way. But there was also this sort of quick way of doing this. We could have done it the other way here. So there were these steps. Start with y is fx that we got here. So we got this. We had the function that we just wanted to have the axis the other way around. Yeah. Okay. And then we would swap. So I'll just write it here quickly and then we progress. So it was like this. Plus 32. Okay. And this is our first step, like it says there. Start with y is fx. So now I have the y is fx. It's not very accurate. Then I have to swap the x and y. So then I write it the other way around. This was the second step. Y plus 32. Okay. And then I have to solve for the y, of course. This is not. So now I would solve for the y. That's the third step. So I would have, for example, I would throw that on the other side or diminish it and swap the sides as well. So I would have 9/5 of y would be x minus 32. Yes, this is the normal procedure that we did before. So I have here swapped the sides and I have, what is this called? What is this operation now in English? Yeah. Yes. What was the official name? Subtracted. Yes, this. And then I would need to get rid of this. So then I just get rid of that. I multiply with the reciprocal. We should talk about the reciprocals a bit more clearly as well. So then I have solved it for the y. So I get rid of this when I just have y is 5/9 times x minus 32 times 5 divided by 9, which is the same. I'll write it once more here. 5/9 of x minus, this is the 160 divided by 9. So this is exactly the same that then you just like swap the axis. Like we did here, we swapped the axes and then we did it this way and we got exactly the same result here. I just wanted to show you that also you could have done it this way. Just like basically, because I forgot to do this. So that was the other way of getting the inverse function. Okay. Just like quickly and easily. Okay, now I need to do one thing. It's the wrong way there. Because it needs to go to a new window. Like that. Okay. So then the right triangle is the next topic. And I think many of you have been already working on that. Who has been already working on this with the quiz? Okay, but here is anyhow. Okay, just like that. So this is also the material from the project, the COCO project. Now it always wants to put some kind of advertisement there. Triangles, basically. Sum of all angles in triangle is 180. The area can be solved with this kind of a formula. So it's the area, is just you multiply with half. This is A, the bottom, and then the height. For sure, all these this equation you've seen at some point. This is also something that you need then in the basic geometry calculations. Yeah. A is the base, and H is the perpendicular height. Then there are you can name those triangles different ways. You can have a triangle where all the sides are equal or two sides are equal. Or then you can also have a right angle triangle. This is the one then that's like important to us in this topic. Right angle triangle. And then there is all sorts of exercises. You can try them. I didn't manage to do anything with this, but maybe it works, maybe it doesn't. Okay, the Pythagoras has given us this kind of dependency, so that if you have the right angle triangle, those sides, if you put them into the power of 2 and add together, it's the basically the length is the same length in the power of 2 added together is the same as the length of this by the power of 2. And this is actually the area, yeah? So the area, if you look at this, I don't have the Wikipedia page now here. We can quickly look at it. If I put it there, right triangle. Maybe not but everything here. In this kind of basic maths articles, the Wikipedia is always a good source. So here is there was somewhere some kind of animation. That was good, but now I can't find it. Okay, but anyhow, there you can find this kind of animation for sure. Now I couldn't find it, where it shows clearly that if you draw a what is it called? Nelia. Now I don't remember again anything in English. Nelia in English, something here. Yeah, a square. Yeah, if you draw a square here on both of the sides and on this hypotenuse, then the sizes are the same. If you calculate these two sizes together with this size of the square here. It's really difficult somehow in English to explain this. I don't know if it made any sense, but for sure all of you have seen this kind of animation at some point. Who has seen this kind of an animation? Who remembers seeing it? Yeah. So it's interesting. For sure you can easily find it. It shows it. It's not on this side though. And here then you have these examples, simple examples that you can solve. For example, you can solve something like this. You know the sides, and then you want to know this length, and then you have to take the square root finally to get rid of the power. We weren't actually in the roots yet, and this is more. Do we have? I don't know if we really now have that kind of calculations, but what we will have. So the basic trigonometry is what we do mainly now. And then there's just how these are named. So there's sin, cosine, and the tangent. Have you been using these now in the physics already? Have you been calculating like a force, for example? Forces, no. Okay, maybe you're not doing something like that now with Jakob. Usually in physics and this time basic physics, you do this. So you know some kind of that. Okay. I don't try to say it now in English because it's not working, but a bit later then. Anyhow, the sin is opposite divided by the hypotenuse and cosine adjacent. How do you pronounce this? Adjacent divided by hypotenuse and then tangent opposite divided by adjacent. And here are a lot of examples how you do this. Maybe it's just better that we basically start calculating this. Yes. So this is mainly that you realize the concept and you are able to use your calculator to calculate this as well. And then it's to do with some kind of sort of real life problems, like in the physics, you usually calculate the forces with this. We will also have something here that you can calculate, where you can calculate forces. Resolve force into its horizontal and vertical components. Or then some kind of problems. But I didn't put here the ones that we do in the physics, the ones that are a bit more complicated, because this is not a physics lesson anyway. So it's just simple stuff. And then there is this still the the guidance to do the quiz. And in the quiz you do basically the very basic calculations. If we know the length of the side and angle, and we want to calculate the length of one side. And then you have to it tells you what kind of accuracy you need to use. So then you have to also round. Yes? This is this kind of very simple calculations in the quiz. So just to basically know the concept. Okay, so it's better just to do the exercises and learn like that. Sorry, there are something maybe in Finnish, because this is copied from the Finnish exercises of this topic. So there might be some Finnish text still somewhere. We can start calculating this together, or if you already calculated, then you can continue with some topic that you are in now. And in the technical formulas, you find all of these. So there is the right triangle first on the page 17. There's this thing, the dependency. Wow. Look, there's also Finnish text. The area. That's funny. Yeah, not funny. Then how you calculate the length of the hypotenuse. For sure, I'm pronouncing that wrong as well. Or any side. And then where's the, no, it must be here. The basic trigonometry. So just what do this sin and cosine and tangent mean? This one we don't need anywhere. And mainly we need the sin and cosine. The tangent, okay, why not? And here this right triangle. The unit circle we will need then in the engineering mathematics too. Ha! Looking forward to that. Radiani, yeah, radians, yes. Then we have degrees and radians, and in radians you calculate then on your well, on your topic fields of your topic calculations. You use the radians. Yeah, so this is, here we have to now use the square root, even if we really didn't yet learn how to use it. What can you do? The square root is here also. Root. So this starts, the technical formula starts with the root. The square root of course means that it's the, here you would put the number 2. You don't need to put it, and you can remove the well, here it's maybe a better expression, or here. So these are inverse operations, taking the square root and raising to the power of 2. Yes? So if I want to kill that power there, I have to do it with the root. And then what this says here is that you get the absolute value, which means that that's in the power of 2 can be either negative or positive. Yeah. So you usually even write like this. But of course here it can't be negative. It doesn't make any sense. But in some other kind of calculations then. And then you have this root somewhere there in your calculator. Yes. So you just write the number there, and just like that, you get something out of it. You can't really have like a negative length. Yeah. And there were even not any unit, 100 something. And then there are more decimals. And then if we want to, if we would want to round it, then what is the correct rounding for this? Is this accurate or no? We don't really know. Maybe 141 or 140, but it doesn't matter now. It's just an example how to calculate this. So there, if you have the side, so you would know that, again, the A here in our, oh, did I put it? Yes, that way or that way. So C, I put it the other way. C is A plus B in the power of 2. So now the X would be, for example, the A. Our C is here 50. Obviously, it's the longest side, it's the hypotenuse. And then X plus. Do you find this really easy? This is really easy. Yes. Okay, good. Good. And then we would just need to solve for the x. Yes. So again, this is of course what we wanted. And then we would have it on the other side alone, and the rest on the other side. Yeah. So I would have swapped the sides, and I would have also taken that out, because I want the x to be alone, and then I just take the square root. I don't even have to calculate this. Like, I can just like do it just like that. Take a square root of the whole expression. And to know how to do it here with my calculator, this is super simple. And why is it super simple with my calculator? Because this square root reaches the whole operation here. Some of you might have to put the brackets, yeah? If you have a different kind of a calculator, and it takes the square root only of the first number. Yes. But this is exactly the same thing. Well, I could have obviously just calculated, because this was even a, how do you say? If I would have just, but whatever, it's 40 or plus minus 40, but now obviously it's just 40 because it's a length. So in the next, you should calculate the marked part, so it can also be an angle. And then if this is like self-evident to you, you can also do the quiz or something else, some next topic. As long as you know how this goes. It's a bit of a pity that in the physics you're not doing the same at the moment with the forces, but what can you do? Maybe at some point you will. Or maybe you won't. So here, obviously, this A is the one that one should solve. And then, of course, you need something more than this. So you have to go to this trigonometry page and then find there some kind of a dependencies that you can use, because you know already the lengths of all the sides. So obviously, if you know lengths of all the sides of the triangle, you can use any dependency here. You can use the sin or the cosine or the tangent. I'll take the first, for example, the sin. Why not? So the sin for me there, which is the opposite, divided by the hypotenuse. And the opposite seems to be 30. The hypotenuse seems to be 50. Okay. So now I have the sin there, and then I want to have this alone. What do I do now? You know how to do this with your calculator, maybe. Yeah, you take this one there, maybe. I don't know if you can see. Yes. So we have to take again the inverse function of the sin, which in my calculator looks like sin minus 1. Well, this is a good expression. In the Excel, it would be a sin, I think. Yes. So then with this inverse function, just like here, this was the inverse function of the square root, the inverse function of the power of 2. If we want to kill the sin, we have to take the inverse function. Yes. And when we take it, of course, it goes to the both sides. So it kills that. So there's only the angle, which we wanted. And then on the other side, we have it as well. And now you just have to know how to use the calculator to do it. And then you have to, now we want to have the degrees. We don't want to have the radians. Radians? Is that how it's pronounced? Yes. So in my calculator, it says it has this kind of a small d there. So I know that I get the degrees. So it was 30. Oops, I'll do it the other way. Put it like this because it looks better. Like that. Oh, sorry. Now I'm doing something wrong. I didn't take the inverse, did I? This is, now I'm getting something weird. So if I now do like this, what is this? Maybe it's not the angle. Now we would already know that this is too small number, yeah? No. So I have to still do like this. Now I'm doing the correct operation. And then I get something reasonable there. So that most probably is what I'm supposed to get, yeah? And some decimals there, H7, for example. Of course, I would need to round this to, for example, 37. That would make sense. Yes. So if this kind of a calculation is in the exam, everybody knows how to do it. Somebody might even fall asleep doing it, yeah? No. Yeah, so I could have picked anyhow any of those functions. I could have picked the cosine or the tangent as well. But now I picked the sin because it was first there. Why not? How about the B? Is it as simple as this? Do you find it as simple? You can think about it for a bit. Maybe it's better that I don't talk all the time. Teachers usually love their voice, sometimes too much. Yeah. Are you doing those quizzes now? Which quizzes are you doing? Graph. Yeah. Does it look easy? It's easy, yeah. Pretty easy. If you want to, we can also look at that. If you want to ask something. But I think it's quite doable. Yeah. Yeah, it's quite doable. It's nice that you do together. Yeah. It's good. Only the exam. No. Yeah. So you can use the time the best the way you want there also correct something. This is like and this way. Then if you have problems with your calculator as well, say like if you get some weird numbers, this is what usually was. You start to present it. People start getting weird numbers bigger than right here. They don't know how. Yeah. What they can do. Okay, I will quickly check how in my calculator I would get it to radians and degrees, if I remember. No, it's not this. What's this? Yeah, it's this. So in mine, it's shift and setup, and then I can pick the angle unit. So I would put 2. And then I would choose which unit I want. Now I want the degree. And then later on, after Christmas, we use both. So then you have to pick. Or then if you use Excel, but we have to use the calculators anyway. You can also use Excel. Who is used to using Excel calculating something like this? Do you calculate in the physics with Excel? Do you use the Excel commands? Functions and stuff? Yeah, but you didn't calculate this yet. In Excel. Okay, I don't know basically maybe how to use it either. Okay, so here this looks maybe like you could have something like this if you have 4.7 meters. This might be a real life thing. Obviously, there's also the one that's been asked is the length of this rise to 4.7 meters when you know that the angle is 30 degrees. So you know again the opposite, and you're being asked to calculate the hypotenuse. So you would pick the sin. Yeah, so sin 30 would be the opposite, which was 4.7 meters divided by the one that's been asked. And then you just have to solve it, yeah? So you can, for example, multiply it. You get it away from there. It's already a better situation. So I multiplied, I got it away from the denominator. And then I would need to have it alone, yeah? So then I would just, what would I do next here? Yes, divide by sin 30. So then I have it alone there, the sin 30 is gone, and it went there to be the denominator, yeah? Because I did the division on both sides. Now with the calculator, I of course now take this, the normal sin. This is not now, this is not the inverse operation, but it's the, you know. Oh, my English is not fluent in this topic at all. What can you do? For sure it will get better in time. And then, of course, this also makes sense. Yes, you always consider, maybe with Jaakko and the physics, you also always consider when you get some kind of a result if it actually makes any sense. Yeah. So here it looks like maybe this is, if this is 4.7 meters, that should be 9.4 meters. The length of this hypotenuse. This looks really similar as the last one. There's just a different function. There's the tangent. Yes. Super simple again. Yes. That one I want. So it comes here. I think this is also very similar as you do in the quiz, isn't it? But you just do it with the stack. Similar stuff. At least then you know. On our department, our side, these kind of calculations are quite important because then there's a lot of calculations with the forces. There's the statics, and then there's some You will do similar things as well in the mechanical engineering. You do the statics and then you do the, what is the other one? Some kind of, I have to look for the word.
There's some of them that also.
Strength, maybe strength of materials. You will do something like this. In Finnish, it would be maybe called lujuusoppi.
As you said?
Lujuusoppi, yeah. And I think for you in mechanical engineering, this is also important. So you do similar things as the ones on the like construction side. So you start with this, and then you just put some things to hang somewhere in different kinds of angles, and then you calculate the forces, and then you will have also the material, how the material behaves,
Yeah.
how it stretches or how it is being pressed, or it has different kinds of variables.
Yeah.
So then you do something similar but a bit more complicated calculations. Yes. So of course you can mark the forces as arrows, and the length of the arrow is the basically the strength of the force. If there is a force pointing to this kind of weird direction, you can always calculate it with its x and y components. This is also like vectors. Are you using vectors in the physics? Vectors at some course you will be using, but we won't be maybe doing the vector operations on this course now. So it's just the length of the vectors that combine in the x and y direction that make the length of the vector that is into some weird direction. Maybe I will actually take something more from the physics to this. So that would be nice, because if you're not doing that kind of calculations now in the physics, then we can do them here. This also makes sense. This is of course shorter than this when you have this small angle, yes?
Yeah.
Yes. How about the 5? Is it easy?
Yeah.
Yes. Did you already calculate it?
I think.
Yeah. It's an easy calculator. But you didn't like have the basic car calculations, no, the physics, where you have the car going somewhere.
Yeah. Some acceleration.
You have an angle, let's say 30, that's quite a lot. You have the car there, and you have the mass of the car. So then you have the G, mg, this.
Yeah.
And then you need to calculate the force, for example, here, to keep the car moving, or then if the car is accelerating. And then you have the other force, that you mark with N. That is the, basically the supporting force of the surface. And then you have to switch the axes to this direction. So you have the Y here and the X here. X is to the direction of the motion. You didn't do something like this in physics. Okay.
We did a spot over.
So you would know some things. You would know the mass of the car. It would weigh 2.5 tons, something like this. You would know the acceleration. For example, what would it be? Or maybe you would need to calculate the acceleration or something like this. Or then you would know that maybe it would be even, it wouldn't accelerate, but it would go on a constant velocity of something. Velocity of, for example, 60 kilometers an hour. I don't know if this goes a bit too much, if there will be too many variables for our calculations suddenly, because then you would know that all the forces together to one direction are mass multiplied with acceleration to the same direction. But you didn't do this, which is the Newton's second law. These are like very, very basic calculations that you do if you go to high school and you do physics. You do this kind of calculations, like many, many like different kind of very calculations. And then here usually the physics almost starts with this.
Yeah.
And why do you want to calculate the cars? Okay, well, you're mechanical engineers, but this is the same stuff. Then the forces, you learned this law, you learned to draw this, and then this is also even if you have something stationary.
Good.
It's basically similar setting. Here it's moving, okay, but then when you have it stationary, you have to have the acceleration 0. So you have to have all the forces are 0.
Yeah.
If it's, stationary, if it doesn't move. Okay. Maybe I could figure out a couple of calculations like this, but I don't know if they get a bit like, if there's a bit, well, let's see. Okay, so the 5 is something a bit like similar anyhow, or similar. So you have the car. Oh, how to draw a car like that. Yes. Did you ever end up somewhere stuck on when it was like ice. You did? In your home country? Hmm. Yeah. And you put something, you don't put winter tires, but you put some weird things on the tires. You don't use winter tires, but you put some, if you go to the mountains, you put some chains or something. Nothing. Okay.
And where I grew up, it's like as soon as you come out of the neighborhood,
Mhm.
it's like they're all held. So
Ah.
was it like on a-
Yeah. Okay. Oh, I'm putting. Which one is F1 and F2? 0.6. Why is it longer? Whatever. So this is the resultant force in the x direction. You just have to calculate the components to the x direction of the both of the forces, yeah? So there's one component and another component. This component of, for example, this force is until here. Here's like the fx2. This now in my picture, these even look the same length. And then here you have the, it's a bit shorter, fx1. So the resultant force, of course, resultant force F, well, I can mark it with R, for example, is of course, let's be, okay, x direction, to be clear. Then you, of course, put the fx1 plus the fx2. So all you need to do is to calculate them with the trigonometry and just put them together, yeah? Easy. Well, I'll write it a bit differently. Why am I doing that? Mess. This makes sense? Yeah, it makes sense. Good. So I have got here x1 is 8 times cos 30 and 2 6 10 times cos 20. It would be good if we would be doing in the physics something similar, you know, so. Well, what can you do? This was fx resultant. Then this. Yeah. This the Newton second law stated this, that all the forces calculated together, which were is the MA, and they have to be into the same direction. Yeah. So now our acceleration is to the x direction. That's how we basically model it in a simple way. And then we knew something, the core's mass, 1.2 tons. Tons, which is 1.2 times yeah, it means just yeah 0.6 0.3 kilograms, because we are in kilograms. Yes. No, forgot. And the kilogram is the SE unit anyway. Yeah? So that's fine. And here, a Newton is an SE unit as well. Which would be 1.3 times Newton, because you have to have everything in the SE unit to get it out in the SE unit, yeah? So just now we want to solve the acceleration here. Obviously, we would be dividing, yeah? This is what we got with the mass. We just have to have everything in SE units. So the force was this one. I could also write it with the zeros, but whatever. I just put there times 10 in the power of 3, because kilonewton is not an SI unit, but the kilogram is. That's a bit like, I can also put it here like this, 1.2 times kilograms, which would mean that I could take this out, yeah? Because it's the same term there. Bye-bye. Yeah, and I can't put this as 1.3. I have to put it more accurate value. Yeah, 2, 6, 1.2. But in Excel, you always keep all the decimals anyway. Now we're calculating with the hand calculator, because we are just learning the very basic ways of handling the equations. Yeah. 0.047 squared, which is, well, 1.0 maybe. Okay. Are you hungry? This was pretty simple, yeah? Did you find it simple?
Yeah, I thought about the compare the on this number 5. You've done 10 to the power of 3. I forgot to do that.
Yeah, but otherwise you did it correctly. Yeah. Simple calculation. Usually the physics calculations are pretty simple as well, as long as you know what the letters mean, yeah? What kind of equations to use. Good. Thank you.